In our times to campus 4x4x5 dataset, we have the factor of route with 4 levels, the same ones we saw before, 4 levels for time of day, the same times we saw before, but now we have a new factor with 5 levels, so day of week. And our interest will be, of course, in whether there are route effects, time of day effects, or day of week effects, but also whether the route effects depend on day of week, that would be one interaction, whether the time of day effects depend on day of week, that's another interaction, whether the time of day effects depend on route, another two-way interaction, and finally, whatever two-way interactions we have, let's say between route and time of day, whether those change across the different days of week. So our final three-way interaction. Now, as I told you before, the first thing you should always do when working with a new dataset is use distribution under Analyze to make sure that overall your variables look well behaved. So I'll take all of our variables and cast them into the Y role, and let's just do this fairly quickly. Looking at time to campus, it looks like everything is okay here, no outliers or strange observations. The distribution is even fairly normal. We have equal numbers of observations for every day of week, route, and time of day. This was, of course, intended for this data set, but in general, you want to make sure you have relatively equal numbers of observations for each of your overall factors. Now, as I pointed out, we really want to make sure that we have each combination of the different factor levels, and the quickest way to do that will be using tables summary. So under table summary, as I showed in a previous module, we can take our different factors, put them into the group section. I'll take time to campus, click statistics, and designate N as the summary statistic I want. So when I click OK, we'll get a table that shows us how many observations we have in each of our combinations. In this case, we have 4 observations for every combination of our factors, which is a perfectly orthogonal design. So an orthogonal design is just one in which we have equal numbers of observations in every cell. Now, I mentioned before that's not a critical assumption of the analysis of variance, but you should make sure that you have relatively equal numbers of observations in all your different conditions. And you certainly want to make sure you're not missing any observations. So you don't want a condition in which you've never observed any of the Y response.